Welcome to lesson 1.2, more patterns in division. So we've already looked at divisibility patterns for numbers 2, 4, 5, 10, and 8 last lesson. And so today we're going to finish off with looking at divisibility patterns for the numbers 0, 3, 6, and 9. So I am looking on page 10 and 11 in the textbook if you would like to follow along. So we're going to look at the divisibility rules for 3 and for 9, and we're going to do it together because the divisibility rules for 3 and for 9 are the same, so we might as well just do them together. So I'm going to start this one by just writing down, let's look at divisibility by 3 first, by writing down a few equations and some numbers that are divisible by 3. So if I write down 27, I know 27 is divisible by 3 and that equals 9. I know that 12 is divisible by 3, and that equals 4. I know that 18 is divisible by 3, and that equals 6. I know that 453 is divisible by 3, and that equals 151. And then lastly, I know that the number 246 is also divisible by 3, and that equals 82. So just by looking at these numbers, there's not really a pattern or any rhyme or reason for why I've chosen those, but what I want you to pay attention to is the number that we divided by 3. And again, there's not really a pattern with those numbers, but what I want you to think about and look at is what pattern or what do you notice when you add the sum of each of the numbers? And so what I mean by that is when I add 2 plus 7, what do I get? I get 9, and 9 is divisible by 3. When I add 1 with 2, that equals 3. 3 is divisible by 3. When I add the number 1 and 8, that equals 9. 9 we know is divisible by 3. When I add 4 plus 5, that's 9. Plus 3, that's 12. I know 12 is divisible by 3. And looking at our last one, when I add 6 and 4, that's 10. 10 plus 2 is 12. I know 12 is divisible by 3. So our divisibility rule for 3 is you just look at the number, and when you add up the sum of the digits, if that sum is divisible by 3, you know the whole number will be divisible by 3. So for example, if I write down, I'm just going to make up a number, 561, and I say, is that number divisible by 3? What we would have to do is add up the digits. So 5 plus 6 is 11. 11 plus 1 is 12. And we know that 12 is divisible by 3, so yes, that number, 561, would be divisible by 3. Okay, so the same thing applies for divisibility by 9. So let's look at a few examples here. 27, I know, divided by 9 is 3. I know that 18 divided by 9 is 2. I know that 315 divided by 9 equals 35. I know that 702 divided by 9 equals 78. I know that 72 divided by 9 equals 8. Okay? So the same sort of thing applies. Just to look at the number and know whether or not it's divisible, we add up the sum of all of the digits. And if it is a number that is divisible by 9, then you know the number would be divisible by 9. So again, let's look at 2 plus 7. That's 9. 9 is divisible by 9. 1 plus 8 is 9. Divisible by 9. 5 plus 1 is 6. 6 plus 3 is 9. That's divisible by 9. 7 plus 2 is 9. Divisible by 9. 7 plus 2 is 9, which is divisible by 9. So you get the picture. So let's do one example. So if I do 1,275 and I say, just looking at that number, is it divisible by 9? You're going to add up the digits. So 1 plus 2 is 3. 3 plus 7 is 10. 10 plus 5 is 15. 15 is not divisible by 9, so that number would not be divisible by 9. So the rule is the same for divisibility by 3 and divisibility by 9. You just add up the sum of the digits of the number you're trying to see if it's divisible by, and if it is divisible by 3, and if it's divisible by 9, then you know you have your answer. So the divisibility rule for 6 is rather simple, and just the way to think about the divisibility rule for 6 is a number will be divisible by 6 only if it is divisible by 2 and 3. And we've already gone over the divisibility rules for 2 and 3, so you should have an idea of how you figure those ones out. So just to think about that, we're just going to make a really quick Venn diagram. So I'm going to put down a series of numbers. So 12, 21, 42, 88, 135, 246, and 728. And I'm going to make a quick Venn diagram just to kind of illustrate this point about how divisibility works. So this side of my Venn diagram will be numbers that are divisible by 2. This side of my Venn diagram will be numbers divisible by 3. And then the numbers that fall in the middle part of our Venn diagram will be numbers that obviously are divisible by 2 and 3, and therefore will be divisible by 6. Whereas the numbers in the outsides of the Venn diagram will not be divisible by 6. So let's look at some of these numbers. The number 12 we know is an even number, so it's divisible by 2. If I add the digits together, that equals 3. So that's divisible by 3 as well, so I know that 12 falls in there because it's divisible by both 2 and 3. If I look at my number 21, 21 is an odd number, so I know it's not divisible by 2, but I know 21 divided by 3 equals 7, so it's divisible by 3. And I know if I add my digits, 2 plus 1, that equals 3. 3 is divisible by 3. If I look at the number 42, I know 42 is at least divisible by 2, because it is an even number. And if I add my digits, 4 plus 2, that equals 8. 8 is not, 6. 4 plus 2 equals 6. 6 is divisible by 3, so therefore it goes in the middle. 88. I know 88 is divisible by 2 at least because it's an even number. If I add 8 plus 8, that equals 16. 16 is not divisible by 3, so I know 88 goes in this side of my Venn diagram. 135. If I add up my digits, 5 plus 3 is 8. 8 plus 1 is 9, so I know 135 is divisible by 3. It's an odd number, so I know it's not divisible by 2, so it goes in this side of my Venn diagram. We got 2 more here. 246. If I add up my digits, I know it's at least divisible by 2 because it's an even number. 6 plus 4 is 10. 10 plus 2 is 12, so therefore I know it's divisible by 3. So I know that this one is divisible by both. And my last one, 728. It's an even number, so I know it's divisible by 2. If I add up my digits, 8 plus 2 is 10. 10 plus 7 is 17. 17 is not divisible by 3, so I know that this only goes on the 2 side of my Venn diagram. So basically what this Venn diagram represents, 88 and 278 are only divisible by 2. 21 and 135 are only divisible by 3. These numbers in the middle here, 12, 42, and 246, those are divisible by both 2 and 3, and therefore these numbers, you can check my math, will be the only numbers out of this set of data that is divisible by 6. Because like I said, your divisibility rule for 6 is your number has to be divisible by 2 and by 3. The last divisibility rule we're going to look at is divisibility by 0, and this one's kind of simple. In short, there is no whole number that can be divided by 0. If you try to type it in your calculator, it will come up with an error message. There's no number that can be divided by 0. And so if we think about that, it's kind of an odd thing to think about that. But if we think about it in terms of an equation, a little word problem. If I have 6 apples and I want to share those apples between 3 of my friends, how many apples do my friends get? Each of them gets 2 apples, right? If I have 6 apples and I want to share it between 0 of my friends, how many apples does everybody get? Well, there's no answer to that equation, right? Because there's no people to share them with. So there is no number, there's no whole number that can be divided by 0. It will always come up with an error message on your calculator if you try to answer it in. However, whole numbers can be divided by 0, just kind of going off on a tangent with the same sort of idea. So if I have 0 apples and I want to share it with my 6 friends, how many apples does everybody get? Everybody gets 0 apples because I have none to share. So do you see the difference between these two statements and why one works and one doesn't? So in short, the divisibility rule for 0, I don't know, there's kind of not really a divisibility rule other than no whole number can be divided by 0. So just to end off, I have put up the divisibility rules that we've covered today. So divisibility for 3, for 9, for 6, and for 0. And so just to end off, how about I will put up a number, and I just want you to think about using what you've learned in the lesson today, whether or not this number is divisible by 3, 9, 6, and 0. Okay, so the number, let's do 2,711. Okay, so thanks for watching.